We are in the process of writing chemical reaction, but before writing the chemical reaction, we must be able to write the molecular formula of different compounds. That's why we are writing molecular formula of different compounds. In previous class also, I told you I wrote few molecular formula of certain compounds. We are continuing with the same. Today we'll complete the molecular formula method of writing molecular formula, and then we'll enter into the chemical reaction. Look at this. I have taken many compounds. Here it is written aluminium oxide, calcium hydroxide, etc., etc. How to write molecular formula of this compound? Let's start. I told you in previous class also, at first we'll write this symbol of the element present in the compound, or the radical formula of the radical present in the compound, and then we'll exchange the valency of this element or radical with each other, and we'll write this molecular formula. Aluminium oxide, aluminium symbol Al, oxide means oxygen is combined. Aluminium valency 3 should be given to oxygen, oxygen valency 2 should be transferred to aluminium. Calcium hydroxide, calcium symbol Ca, hydroxide means OH. Now, calcium valency 2, hydroxide valency 1. We don't have to transfer one valency to other. Calcium 2 should be transferred to hydroxide, but while transferring valency to the radical, we have to keep that radical in bracket because the whole radical is 2. That's why CaOH whole 2. Zinc sulfate, zinc Zn, sulfate means SO4. Zinc valency 2, sulfate valency 2, equal valency, no exchange. Now ammonium hydroxide, ammonium, this is a radical NS4, and hydroxide OS. Ammonium valency 1, hydroxide valency 1, equal valency, no exchange. Now magnesium nitride, magnesium is symbol is Mg, nitride means nitrogen is combined, that's why writing N. Magnesium valency 2, nitrogen 3, that's why 2 is given to nitrogen, 3 is given to magnesium. Potassium nitrate, potassium means K, and nitrate means NO3 radical. Potassium valency 1, nitrate valency 1, equal valency, no exchange. Auric chloride, auric, aurus is of valency 1, auric means valency 3 of gold. This is variable valency of gold. Auric means valency of gold is 3 at this time. That's why Au, chloride means chlorine is combined, AuCl. Valency of this gold is 3 at this time, chlorine 1, we don't have to transfer 1, so AuCl3. Cupric oxide, cupric, cuprous means valency of copper is 1, cupric means valency of copper is 2. I told you in previous class variable valency of metal, os means less valency, ic means more valency. Cupric, copper is combined with oxygen, ic means its valency is 2, os means 1, that's why 2 valency, equal valency, no exchange. Now ferric oxide, here also iron is combined with oxygen, ic means valency of iron is 2 or 3, at this time it is 3 because ic means more valency. Iron valency 3, oxygen valency 2, that's why valency of oxygen is given to iron and iron to the oxygen. Mercurous chloride, mercury has variable valency 1 and 2, os means 1, ic means 2. Mercurous, mercury Hg, chloride means Cl, mercurous means 1 valency, chlorine 1 valency, equal valency, no exchange. Ferric sulfate, ferric iron is combined with sulfate radical, ic means valency of iron is 3, and os means 2. Sulfate is valency is 2, that's why 2 is given to iron, and its 3 valency should be given to sulfate, but this is radical, that's why I'm giving bracket, and so Fe2SO4 SO4 whole 3. These are the compounds. Looking at their name, we can write their molecular formula very easily, but while writing chemical reaction, there are many compounds. Looking at their name, we cannot understand whether which element is present in that particular compound or which radical is present in that particular. Just for example, water. Looking at this word water, we don't know what element is involved in water, but this is our understanding that water its molecular formula is H2O. We know previously, that's why we'll be able to write. Otherwise, looking at this word doesn't say that it contains hydrogen and oxygen. That's why we have to remember this. This is commercial name should be remembered because we cannot understand what it means. Just for example, ammonia. Ammonia doesn't say that it contains nitrogen and hydrogen. Its molecular formula is NH3. In the same way, methane. Methane doesn't say that it contains carbon and hydrogen, CH4. And silica. Silica means SiO2. And this silicon is combined with oxygen, silicon having valency 4 and oxygen is 2, and when we transfer and take common, and then we'll get SiO2, but it is written just silica, and that's why we have to remember this. Hydrogen peroxide, this means H2O2. In the same way, these are the acids. Hydrochloric acid, this is HCl. We have to remember this. If it was told as hydrogen chloride, then we'll be able to write HCl, hydrogen, H for hydrogen, chloride, Cl for chloride. But it is, if written hydrochloric acid, we must remember that hydrochloric acid is HCl. Sulfuric acid, H2SO4. And in the same way, nitric acid, HNO3. Carbonic acid, H2CO3. Acetic acid, CS3COOS. Now phosphoric acid, H3PO4. Again, I want to tell you that if hydrogen phosphate is told, if in place of phosphoric acid hydrogen phosphate is if told, then you can write easily hydrogen, S for hydrogen, phosphate PO4, and you can exchange the valency. But phosphoric acid doesn't say that it contains hydrogen and phosphate. That's why we have to remember this. Caustic soda. Caustic soda means NaOS. NaOS. Caustic potash means KOS, potassium hydroxide, sodium hydroxide, normal chemical name. Washing soda means sodium carbonate, Na2CO3. If it was told as sodium carbonate, we will be able to write this, but washing soda we have to remember. Baking soda, NaHCO3, it is used in kitchen. Quicklime means calcium oxide, and slackline means CaOS2. Again, I want to tell you that if it is told as calcium hydroxide, we'll write Ca for calcium, OS for hydroxide, and we'll exchange the valency. But slackline doesn't say it contains calcium and hydroxide. That's why we have to remember this. Now, marble, limestone, or chalk, the same thing. Chemically, they are same. Marble is hard, limestone is soft version, and chalk is more soft, and it is calcium carbonate, CaCO3. And carbon monoxide, what is it? CO. We have to remember this because here this is unstable compound. That's why when we exchange the valency, we'll get a wrong result. Okay, carbon dioxide, CO2. This is very simple. If you try to write this, carbon and oxygen is combined, its valency is carbon, valency of carbon is 4, oxygen is 2. If 2 carbon atom combines with 4 oxygen atom, it means 1 carbon atom combines with 2 oxygen atom and carbon dioxide forms. Why to be bothered with all this? That's why it will be better to remember that carbon dioxide, CO2. In the same way, sulfur dioxide, SO2. Here also it also requires the same procedure. Instead of going through this procedure, it will be better to remember this. Until and unless we are able to write molecular formula looking at the compound, and until and unless we remember this commercial name, which may be given directly in the chemical reaction, will not be able to write the chemical reaction. That's why this is the full preparation of the chemical reaction. If we are able to write molecular formula, we'll be able to write chemical reaction. Okay, next class we'll write chemical reaction. This much for today.